That was in the form of quadratic equation. Okay, right? An square plus bn plus c. Now let's look at the cubic sequence. Cubic means to the power 3, obviously. So it will have a 3 power inside. Cubic sequence. First of all, what is n cube sequence? If we just write n cube, you put n is equal to 1. 1 cube is 1. Okay, is equal to 1. What about 2 cube? 8. 3 cube? 27. 4 cube? 64. 5 cube? 125. So this is a cubic sequence, simple one. 1, 8, 27, 64, etc. The general formula for this can be just n cube. Okay, you put n the position of any number and you just take cube. So now let's look at one cubic sequence. Okay, this is the original sequence that we are given now. Okay, so let's find the common difference. First common difference. Okay, what's the common difference between 18 and 11? 7. Okay, 37 minus 18, 19. 74 minus 37, 37. 135 minus 74, 61. So we don't see any common difference, any same common difference. Okay, let's move to the next common difference. This was common difference 1. Let's do common difference 2. What's the difference of this difference? 12, 18, 24. You can see still the second difference is not same. How about one last attempt? What about third difference? This was number 1, number 2. Now third difference. 18 minus 12, 6. 24 minus 18, 6. So third difference is same. Hence, it is a cubic sequence. Okay. For this one, linear sequence, first difference same, quadratic sequence. Second difference is same, cubic sequence, third difference is same. So if it is a cubic sequence, now how we will find the general formula? First of all, step 1, you write the n cube sequence. Okay. Step 1, n cube. What is n cube sequence? 1 cube is 1, 2 cube 8, 3 cube 27, 4 cube 64, 5 cube 125, and so on. Then what we did before in the quadratic sequence, same thing we will do now. Okay. We will find the difference between original and n cube. Okay. So 11 minus 1. What is that? 10. 18 minus 8. Again 10. 37 minus 27. Again 10. And so on. Every time the difference is 10. So now we are ready to write the general term for this sequence. It is n cube. Pick this one, n cube, and pick this one, the constant difference coming plus 10. We have found the general formula. You can check. This is n is equal to 1, first term, second term, third term, fourth term, fifth term. Suppose you want to find the fifth term using this formula. It is 5 cube plus 10, 135. So it's matching. Okay. Let's look at more examples now. Okay? The original sequence we have is 0, 6, 24, 60. First difference, is 18, 6, 18. It's not becoming constant. Okay. But here we are learning about cubic sequences. This is example 2. 36, 60. So first difference is not the same. Let's look at the second difference. 12, 18, 24. Second difference is also not same. How about the third difference? Third difference is same. So when third difference is same, it's a cubic sequence. So for cubic sequence, try to first write the n cube, okay? N cube. Write the sequence of n cube. N is equal to 1. 1 cube is 1. N is equal to 2. 2 cube 8. 3 cube 27. 4 cube 64. 5 cube 125. All right. Now try to subtract original minus the n cube sequence, okay? Original minus n cube, that means 0 minus 1, which is minus 1, 6 minus 8, minus 2, minus 3, minus 4, minus 5, and so on. So now we can see that it is another sequence. The original minus n cube is giving us another sequence. So we can find the general term for this sequence. This is obviously a linear sequence. You can see always the difference is minus 1. So that is very simple to find. For this part, Tn is equal to a plus n minus 1d. Very quickly we can do a is the first term, minus 1, and minus 1. D is the difference, minus 1. What is it? Simplify, minus n. That's it, minus n. The other term will cancel, 1 will cancel. So we have minus n here and we have n cube here. The general term formula is Tn is equal to n cube minus n. Okay, so quickly I'm explaining again quickly. Original sequence is this. We decided that we came to know it is a cubic sequence because the third difference was same. Not the first, not the second, but the third. Third difference same, write n cube sequence. Then find the difference. If it's constant, just give that number. But if it's again a sequence, try to find the general term for that sequence and combine it with the n cube. Okay, let's move on. One more example of cubic sequence, and we can do the practice. The original sequence is 2, 12. Let's find the common difference. First common difference is 10. What about the second common difference? Second common difference is also not same. About the third common difference, that is same, 6, 6. So again, it's a cubic sequence. For cubic sequence, write the n cube sequence first. 1, 8, 27, 64, 125. Find the difference, top minus bottom. 2 minus 1 is 1. 12 minus 8 is 4. 9, 16, 25. Now, this is a special kind of sequence. Do you recognize that? Any idea, Riharami? Any idea what is the journal term for that?
N square. N square.
Sorry, the n square, exactly, because 1 square, this is 1 square, this is 2 square, 3 square, 4 square. So that means this is n square. So you just combine them, n cube and n square. So journal term formula for this sequence is n cube plus n square. Fantastic. And let's check. For example, this is 1, 2, 3, 4, fifth term. Let's find the fifth term. 5 cube is 125. 5 square is 25. So this is 150. It's matching the fifth term, matching the answer. Okay, I'm deleting this is very important, these sequences. Let's move to the worksheet I have shared in the Skype group also. And there is another worksheet. I made two. So after we complete the one, these are from paper 4. Okay. Paper 4 accounts for 70% of the final grade. Okay. Paper 2 is 30%. All right. Let's start. If you know the answer, you can tell me. Find the nth term of the sequence. Nth term means the journal formula. Okay. So what's the common difference? 2 minus 4 minus 2 minus 2 minus 2. So this is just a plus n minus 1 into d. Okay. The linear sequence. 4 plus n minus 1 minus 2. Minus 2n plus 6. Okay. Let's check out the second sequence. What kind of sequence is this? Find the common differences and see. Then it's not linear, obviously. What about second difference? 4, 4, 4. So that means second difference is same. So it's a quadratic sequence. Riha was able to solve it yesterday, quadratic sequences. So you can try again. Quadratic sequence, we need to write the formula n square first. Okay, sorry, not n square. It was divide the second difference with 2. Okay, so 4 by 2, then n square. So which is 2n square. So write the sequence 2n square. N is equal to 1, 1 2s are 2. N is equal to 2, 2 2s are 4, 4 2s are 8. 3 3s are 9, 9 2s are 18. 4 4s are 16, 16 2s are 32, and so on. Then find the difference. This is the original sequence. This is the new sequence. 1 minus 2. 1 minus 2 minus 1. 7 minus 8 minus 1. 17 minus 18 minus 1. 13 minus 1. So it's always minus 1. Combine it with this 2n square. You have got 2n square minus 1. No problem. We can move on. Okay. Okay. Now we have different kind of sequences. But here I need to first of all explain one concept. We need to learn one more sequence, which is very easy actually. But the general formula I want to tell, geometric sequence. Geometric sequence is something like when you divide or multiply with a number. Okay. Example, what is this sequence? 2, 4, 8, 16, 32. What is happening here? I think we saw this before also. It's just multiply by 2 every time. But what about the general formula? We need to find the general formula. General formula will be, you can note this down. This one you need to remember. A r raised to power n minus 1. Very useful to remember this. What is A? First term. What is R? It's common ratio. We don't have common difference here. We have ratio. So that is any consecutive term ratio like T2 second term over first term, or third term over second term, or like 100 term over 99 term. So what is R here? R is equal to 4 over 2, 2, which is you also see here. Okay. N is obviously just the position of the term. So what will be the final formula here? Tn is equal to A is 2 times R. R is 2 raised to power n minus 1. You can leave like that, but it's recommended to simplify it. For example, 2 raised to 2 is 2 raised to power 1. You can use indices 2 raised to power n. 1 minus 1 is 0. So it just, you can also write 2 raised to power n if you want to simplify. All right. Let's look at one more geometric sequence. How about this one? 100, 50, 25, 12.5, 6.25, and so on. What is happening here? I think you already observe it. Dividing by 2, right? We are just dividing by 2 every term. So what will be R here? R is again, you can say T2 minus T1 or T3 minus T2. It's 0.5, okay? 50 over 100 is equal to 0.5. And A is 100. So what's our general formula? General formula is A 100 times R is 0.5, 0.5 raised to power n minus 1. All right. If you want to use it, let's find the term, for example, third term here. T3 is 100 times 0.5, 3 minus 1, okay? 100 times 0.5 square, 25, okay? Same as the term. Okay, I hope no problem here. AR raised to power n minus 1. Let's go back to our question now, because we will use it here. All right. Please tell me the fifth term and the journal formula. Can you solve it? It's very easy. The A sequence is very easy. Can you try? 30 seconds, I'm waiting, okay? Okay, what do we have? Basically, it's just the cube numbers, right? It's n cube. This was 1 cube, 2 cube, 3 cube, 4 cube. 5 cube is 120. Okay. What about the next one? Is it a linear sequence? I think so. It's linear sequence, right? 6. The difference is always 6. So just add 6, positive 6, obviously. 29. And use A plus n minus 1 into D. A is 5. Minus 6 plus 5 minus 6n minus 1. Okay. Let's do the third one. Third one, as you can see, they are just multiplying with 2. Multiply 2 with 2.5, 0.5. Again, multiply by 2. Multiply by 2. So how this is a geometric sequence, right? Where a constant term is multiplied or divided with a number. So the general formula will be AR raised to power n minus 1. A is 0.25, first term. R is the common ratio. 1 divided by 0.5 or 2 divided by 1. Common ratio is 2. Okay. Raised to power n minus 1. You can simplify, even though this is the final answer. But if you want to try some indices simplification, what is 0.25? It's 1 over 4. 1 over 4 is 1 over 2 square. 1 over 2 square, you can move up, change the power to negative, and then you add the powers. So n minus 3. You can also write over Tn is equal to 2 raised to power n minus 3. But it is optional. Even the first one is accepted. Okay. What about the last one? Last sequence, we try to solve, we will never be able to solve. Like if we try to find the differences, they will never become same. We can try. Exactly. Exactly. Because if you try to find differences, it will not be able to solve. So what Riha is doing, B minus C, because every time when you subtract 0.25 from 5, you get 4%. Subtract 17 minus 1, you get 6. So you can subtract the formula also. Okay. So 6n minus 1 minus 2 raised to power n minus 3 or minus this. All right. Let's move